So what we're talking about is the Earth's northern polar ice cap. And what that's made of is ice that's floating on top of the Arctic Ocean. And this is ice that's anywhere from like 3 feet at the thinnest to about 20 feet at the maximum. And we're interested in this ice for a couple of reasons. The first thing is right now it functions like a giant mirror on the top of the planet. And when sunlight comes in, it reflects those rays of light back into space. Well, ice has very different reflectivity than water. Water is a lot darker, so as that ice retreats, we get more dark water exposed. Now that incoming solar radiation gets absorbed, and it heats up the water. And that also increases the amount of ice that melts. Now, something you need to understand too is that that ice is dynamic. Every winter it grows and continues out, and then every summer it melts back. The reason people are concerned right now is that in the past few years, we've seen a dramatic summer melting that takes the ice back to a point that's far, far, far smaller than we've ever seen it before. And in 2009, we set the stage for another year of this continued melting and reaching what are near record lows. This is important though, not just because of how much ice we have in terms of extent. The thickness of that ice is also important. And in 2009, what we also released were some new satellite results where for the first time we were able to figure out what the thickness of the Arctic ice is all over the place. And what we're finding is that it's thinner now. And that also, thinner ice is easier to melt than thick ice. And so all of this is setting the stage for predictions of an Arctic that is ice-free in summer months somewhere in the coming decades. Now, we don't know when it's going to happen, but it's the kind of thing that a lot of people are working on trying to model. But it's so obvious that this is happening that people that live in the Arctic regions and the countries that border the Arctic are planning facilities based on there being less ice. There are people building warm water ports. There are oil companies preparing to do exploration. People talking about using it as a transportation route. But also the Arctic peoples that live there, they're observing these changes. And they're saying things like, hey, we used to be able to walk out on the sea ice, and now we can't do that anymore. So these changes are real and they're happening. And what we're trying to do at NASA is, like I say, to go out and characterize this ice. Understand how it works. How is it affected by ocean currents? How is it affected by winds? How is it affected by sunlight? So that we can correlate that with the changes we see in the atmosphere and develop better predictive models. We study the Arctic sea ice with a range of tools. The most important tools are satellite tools. You need to think of this ice as being continent scale, okay? This isn't something that you can get with a single aircraft flight, and that's why NASA is really important, because we operate the satellites you can study it with. Because from that we can tell what the concentration of ice is. You know, is it ice that's a foot thick that's covering everything, or is it little patches of ice? But that's not the whole story. We also need detailed studies. We're interested in how rough is the surface. This ice is, in some places, it's smooth, like that pond in the Midwest that freezes every winter. But in other cases, that ice has been blown and crunched together, and we get ridges and mounds and things like that. We also put people out there on the ground, just walking around studying things. We'll also study it with aircraft. And aircraft are great because the tools we can use in aircraft do different things than satellites or ground studies. We map how much snow has fallen on the ice. We try to measure the size of cracks, as they're called, leads, and put all that information together. Now, why should you care if you don't live in the Arctic areas? That's a really good question. And the fact is this. All this stuff we talk about, when you retreat the ice cover and you heat the ocean up with more sunlight, you also have to think about there's going to be more water evaporating to the atmosphere. There's a lot of other exchanges going on. That's going to change the way that the Earth's climate works, and we expect weather patterns over North America to change. Now, this stuff is very, very difficult to model, but the most recent models suggest is that if we lose the Arctic ice cap, we may have more drought in North America. So these are important things for us to learn about and plan for and deal with.